Hey guys, welcome to today's class. Yes, this is SVR support vector regression. Actually, support vector is used for both regression and classification, but this is the regression aspect. Yeah, so regression is very easy with this model. So let us start from the top. This is the algorithm. This is what you need for the. Let me check if I have an algorithm laid out. Support vector. Don't worry, it's not. Can't see it there. Okay. So you start from the libraries. I should have that thing. Sorry, excuse me. Support vector regression. Support vector regression. Okay. SVM regression. Yes. Yes. So let us explain this algorithm in details. Let us explain this algorithm in details. So for the split data set, split test data set, we need these libraries. Install these libraries. Use pip to install these libraries. We are going to load the data. After the installation, split test the data, and that is the training and testing data. Feature scaling to fit and transfer them to standardize them. Feature scaling. And we are going to be training the SVM model using any of this radial basis function. We can use polynomial, we can use linear, or we can use sigmoid. After then, we are going to make prediction. This is the algorithm. Make prediction. This is the evaluation. Those metrics I told you. Regression. This is a general metric used for regression. All these metrics, this MSE, mean square error, root mean square error, and R square. This is the general metric used for regression to test the performance. Then we visualize. We can further perform tuning. That one will be discussed later. So this is just a detail. I'll be explaining the details to you in the code. This is what I was talking about: RBF, radial basis, linear, poly, and I'll just take this model as a kernel. It's a kind of kernel model where you can just put what kind of regression model you want in one code. You can change it in one code. So this is just a more detailed. So I think there are important lessons below, because I use poly. See the important lessons below. So I'm going to get back to this after I test the code. I'm going to get back to these important lessons. So let us go to the code. So train, we import the library, we load the data set. This is called this data cleaning is also pre-processing. This thing we call pre-processing. Loading transformation is part of it. Pre-processing the data. So we are going to be dropping any row with missing value, and then we are going to be dropping any row with duplicate value here. So that's pre-processing. Features and targets. We are going to separate the features and the targets. The feature column and the feature column are called the X variable, the X, and the targets are called the Y. So we are going to train test them. So our test size is 0.2. That is 20% of the data set. Let me show you. If it's NR we are using, we are going to use 20%. Maybe 20% will be something like this. So we are going to be using 20% to test, and then the remaining of this to train it. Standard scalar, transforming it, reshaping, printing, split it. Now this is the most important part of the code. This kernel. What model do you want it to use? What model? Is it polynomial? Is it radial basis? Is it sigmoid or linear? So the best one that will fit it, just go ahead and use it. After then, this fitting of the model is called training. Sorry, let me increase the brightness. So this fitting of the model is called training. It's called training. After the training, we make predictions. Yeah, all these ones are just meant to, you know, shape them. These codes are just meant for shaping. This is the these are the metrics now we use to score. This is printing of the metrics, and then we are going to be visualizing it here. This is the code for visualization. There's no need to explain all these ones details. Just use whatever you see here. So let's go. We are testing this data set now, this for x3, on this model, on polynomial regression model, in one code. So let's try it. Let's run it and see. Very not perfect. I don't know how to. This is very far from perfect. It's even giving us an R squared of 0 point minus. You can see that the scatter plot is very far from the line. All these points are really far. They are not. It's not accurate. So now when we change it, let's change it. Let's try sigmoid, because the perfect model will be what we will use. That's what we will settle for. We'll settle for the perfect model. Oh, this is worse. Minus 23. R squared is minus 23. Worse. Let's try radial basis. Radial basis is shortened as RBF. Let's try radial basis. Almost perfect. 0.95. 0.95. So this is the model we need. This is, you can see how this line, these dotted lines are close. You can see how these dotted lines are very, very close. The scatter plots are close to this diagonal line. So let's try one more. Let's try linear. Linear. Same thing, almost perfect. So the scatter plot is almost close to, it's almost close. You can see it's not far. You can see it's not far. You can see they are not far from this line. If you check it, they are not far. So that's why it's giving us 0.95. This is 95% accuracy. That's 95% accuracy. So we settle for either linear or radial basis function. So that is it about support vector regression. That's it about support vector regression. Replace your data. Any data set you have, replace it with this one here according to your data set. So this is this code from beginning to the end. Thank you. Well, I think we are done with regression now. We'll be going to classification next. Thank you very much. Thank you.